All right, hi folks, this is Larry Mussolino. I wanted to record a short video to help you in Chapter 8 homework. This is part of Module 6. And this chapter is about different sampling methods and ways to collect data using sampling procedures. So let's take a look at a few examples here. It says, for the following observational study, indicate whether they are prospective or retrospective. So of course, before we can really answer this question, we have to understand some of this terminology. So what is an observational study? What is a prospective study? What is a retrospective study? So to help with that, let me go into the textbook and I'll bring up some background on this. So here I am. This is page 254 in the textbook. And it looks like it says here, a study in which individuals are observed and outcomes measured is called an observational study. Well, the word observe just means to kind of watch and record. So if I'm just recording data from what I observe, that's called an observational study. That's different than an experiment. An experiment is where I take an active role and I ask one group to take some kind of a treatment and another group maybe does not take a treatment. For example, in a clinical trial, I might ask, one group of patients to take a medication. The other group would take a placebo or a fake medication. All right, it says here, a study in which individuals are followed to observe future outcomes is called a prospective study. So notice here it says the word future. So we're going to be collecting data in the future on these individuals. But if we are looking at past data, previous data, right, it says here previous behavior, that's called retrospective. The word retro means in the past. All right, so these are the definitions we need. So let's go back to the question. And we'll take a look at the first one. It says an airline is concerned with new security measures that might discourage travelers. They track the behavior after announcing new security restrictions. So what that implies to us is after they announce these security restrictions, they want to track behavior going forward. Well, that sounds like future data collection. So that's going to be a prospective study. Let's go to the second one. Does giving children a flu shot protect parents? Researchers questioned a random sample of families at the end of the flu season, and they asked whether the children had been immunized. Well, that's looking backwards, right? They're conducting this at the end of the flu season, and they're asking whether children had been immunized in the past. So that's a retrospective study. Okay, so the idea here is if you're thinking about a future data collection perspective, if you're thinking about past data, retrospective. All right, let's take a look at another example. So this one's going to ask you about sampling and sample sizes. It says, indicate whether each statement is true or false. To get a representative sample, you must sample a large fraction of the population. It turns out that's false. It turns out the size of the population really doesn't matter. What matters is the size of the sample. So the answer for this one is false. The fraction is not important. It's only the size of the sample that matters. For example, if I take a sample of 1,000 out of, let's say, 100,000 people, that gives me really the same information than if I took a sample of 1,000 out of 1,000,000 people. So the population size really is not relevant. Let's go to part B. Using modern method is best to select a representative subset systematically. Well, really, we should use random samples. That's the best way to select a representative sample, right? I want to be able to say that my sample is reflective of the population. So the process should be randomized. A census is the only true representative sample. Now, the word census means you're going to collect data from everyone in the population. Well, that's false because you can take a sample, and that sample is representative as long as you took a random sample. So a random sample is representative. And actually, that's the preferred way to do it. I don't want to go out and collect data from an entire population if I don't have to. Let's come to this last one. It says a random sample of 100 students out of 2,000 is the same precision as a sample of 100 out of 20,000. Well, that's true. I just mentioned that a minute ago, that the size of the population really doesn't matter. It's the size of the sample. So if the sample sizes are the same here, it doesn't matter what the population sizes are. It's going to be the same precision here. All right, let's go to another example. Let's take a look at this one. It says, a group of business students decided to survey the student body to assess opinions about a new coffee shop. So they took a sample of 140, and this 140 had 35 first-year students, 35 sophomores, 35 juniors, and 35 seniors. Okay. Do you think the group was selected using an SRS? SRS means simple random sample. So if you went into the student body and selected a random sample of 140 random students, do you think you would end up with exactly 35 freshmen, sophomore, junior, seniors? Well, of course not, right? It would be so unlikely for you to get exactly 35 from each class if you just took a random sample of 140. So this was not a simple random sample, right? It would be impossible to get exactly 35. Well, what kind of sampling method was used then? What kind of sampling design? Well, we call this a stratified sample. Stratified means you take the population and you divide it into different groups or strata, we call it. So I would divide this into freshmen, then sophomores, then juniors, then seniors. Then I would take a sample of 35 from each one of these categories. That would give me an exactly the same number of sample from each of these four classes. So we call this stratified sample. All right. Let's take a look at another one. All right. So they're going to give us a scenario here and ask us some questions. It says a business magazine mailed a questionnaire to human resource directors at 400 companies. So here's 400 companies. And we mailed the questionnaire to the HR directors. And it looks like we only got responses from 29% of them. All right. And so what is the population here? Well, the population is the large group that we're trying to take the sample from. Well, in this case, it's going to be the human resource directors of the 400 companies. What is the population parameter? That means what are you trying to measure for this population? What it says here, we're trying to find the number that don't feel that surveys intrude on their workday. So the parameter here is the proportion of directors who don't feel surveys intrude on their workday. What is the sampling frame? That is, how would you actually select the sample? Well, we would need a list of all the HR directors at the top 400 companies. All right, let's go down here. What is the sample? Well, the sample is the 29% of HR directors who responded. Are there any potential sources of bias? Well, we could have what's called non-response bias, because there might be some HR directors that are not inclined to participate in the survey. If they feel the survey is an intrusion on their workday, they'd be less likely to respond. So that could introduce some bias in the responses we get. Okay, folks, by the way, remember that when you're working these examples, use the Help Me Solve This or View an Example buttons. Those are very helpful. Remember also, you can open up the textbook. If I click here, textbook is available, so that will take me to the section of the textbook where these concepts are discussed. All right, folks, hope this is helpful as you're working in the Chapter 8 homework.